Yes. Uh-huh. Again, one more time. For that, you need to copy the ISO on the Hyper-V server, and from there you work it out. Okay. Okay. I cannot move this because this is recording. Okay, okay, so guys, Farah had a question. Yes, some of these labs are very confusing. Some points are confusing here, but guys, the real life is more confusing. So this is kind of fun to figure out is by hitting try this and that. This is the ability to work with these numbers. If these steps are 100% step by step, so I'm not saying that errors are put into the book deliberately, but maybe there are some misconfigurations there. But I can tell you this book that we are using is recommended by Microsoft. Number two, this is the official Microsoft. So official Microsoft does also may have errors. So it's fine. Just try your best and hit the try and go. Now you know that you can send a message, you can bring it here and help you out and those things. Yes, 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 for sure. This is what? Yeah, he's stuck somewhere. A couple of years. That's fine. It's fine. Guys, I think I already told you. I already servers are very good servers, but they are among the most unstable operating systems right now in the world. Unix is very stable. Linux is very stable. Router switches OSs are very stable. But Microsoft so many things work on the server, the server becomes unstable. So it's very normal. It's fine. Whenever you just let me know or try to go through it. It's better to do them in a group. So if you're in a group, then go through them in the way. Guys, today's lecture is very very important, and today's lecture is all about IP. I'm trying to record this as well. I don't know that if it can capture fully the whiteboard here. But the main idea here is so wherever you miss something, you can go back to this. So this is very important. Actually, today's lecture is all about IP address. So this IP address, guys, this will make our server infrastructure. If you're not able to understand what is an IP address, today's all lecture is about fine, fine. So So today's our lecture is about IP address directory. Now, what is IP address? How IP addresses are made? How do we define IP addresses? Why are we using this today? So today it's all about IP address. So it's very important to understand. I would highly recommend make notes because when you make notes, when you start writing about something, it automatically goes into your brain and it also initiates some questions as well. So, IP address. First of all, few things that we already know. Few things. First of all, IP address is a unique number assigned to all network devices. IP address is the unique number assigned to all network devices. Now, for example, computers, servers, smartphones, switches, routers, all of them. So without IP address, two devices cannot talk over a network. Two devices must be able to talk to each other. So IP address, a unique number assigned to all network devices. And what are the devices? Computers, servers, smartphones, switches, routers, whatever need to communicate over a network. So you must have an IP address. Now, what is an IP address? So, uh, so in our case, guys, let's relate this to what we already have in our network. We have two servers in our network right now. We have one client, and we have assigned them some IP addresses in here. So this is an IP address. This is IP address. This is IP address. What can we relate it to in our life? It's like either a SIN number that is assigned to us we can track down all our activity just through this one number, or it can be a cell phone number. Cell phone number. So it can be a cell phone number. The cell phone number is also unique throughout Canada. No two people have the same cell phone number, so it is one. So it's just a number with which these machines are distinguished. So just like with SIM card, we are distinguished. You have a different SIM card, you have a different SIM card. In the same manner, each computer has to have a different number. Now, okay, so we know that okay, IP address it's a unique number. Now, what is the IP address? Where does it come from, and how does it work? So guys, IP address is defined so IP IP address came from Internet Protocol. So IP stands for Internet Protocol. Internet Protocol. So IP stands for Internet Protocol. Now it's not important to know what is an Internet Protocol, and you don't need to go into that history, but it's just that you need to know that what IP stands for. IP stands for Internet Protocol. Now it was just known as Internet Protocol. You have to say something. TCP/IP uses this number. So we'll later go into this. So it is IP stands for Internet and it's the address. So whenever you address. So the address of this machine is this number. Address of this machine is this number. Now guys, IP address currently there are two types. So IP address there is something called IPv4, which is version 4. So V stands for version and 4. And then there is another one IPv6. IPv6. IPv4, IPv6. IPv4 is a older technology and IPv6 is the new IT technology. IPv4 is older IP technology and this is new IP technology. Now guys, these all IP addresses are based on some numbers. So here, this IPv4 is also known as a 32-bit address. So this is known as 32-bit address. Whereas IPv6 is 128-bit address. So 32-bit address, 28-bit address. So this is a 32-bit address. And IPv4 IP address is divided into four parts. It is divided into, it has four octets. It has four octets. And octet is a part. So it has four octets, and IPv4 address can be written in this manner. So it has four parts. each part is divided by a dot. So this is how it is. And this is what is known as octet. So each one is octet. So IP address is made up of 4 octets. It has 4 octets. Just like here we have 4 parts. So 1, 2, 3, and 4. So you have 4 parts. So IPv4 IP addresses are of 2 types. How many types? 2 types. So this is IPv4, and then you have IPv6, and then IPv4 is older technology but still in use. IPv6 is a newer technology, and IPv4 is known to be a 32-bit address, whereas this is known as 128-bit address. Now, so IPv4 is it has 4 octets, and each part. So we can in our normal language we can call it, these are IP addresses divided into 4 parts. Just like a telephone address is divided into 3 parts. So you have 416.7105. So here it is said whenever in some places these numbers, it automatically divides it into these parts like this. So just like this, IP address is automatically divided into 4 parts, and we need to remember it in 4 parts. You won't find a IP address, IPv4 IP address, other than this format. It is always this format. Now, each octet, each octet is made up of 8 bits. Each octet is made up of 8 bits. So here we can say each octet is made up of, each octet is made up of 8 bits, which means that each octet is made up of 8 bits. So each octet has, so here I can say 8 bits. And 8 into 4, 8 into 4 is 32. This is why it is known as 32-bit address. So here, let's write the bits in each part. So if I take just one part and I need to write 8 bits. So a bit is a smallest value in measurement. Uh, so so here I would say, so this just one part, 1, 2, 3, 4, 5, 6, 7. So this one octet is made up of 8 bits. This is one octet. And it is divided by dot, and then 8 more bits. 1, 2, 3, 4, 5, 6, 7, 8. And again divided by dot. So total 32. Total 32 bits. This is why it is known as 32-bit address. What? Yes, exactly, exactly. Each and 8 bit, this is why it is called 32-bit address. So excellent. Now we know where this 32-bit came from. So IPv4 address is known as 32-bit address. Why is it known as 32-bit address? Because it has total, this complete number is made up of 32 bits. And in order to make us easy to remember for us guys, if this would have not been divided into this, then it was very hard to remember something like this: 128, 192, 168, 100. So this IP address, and look at this number. So it is difficult to remember, whereas this is easier to remember. So yes, this is so now it is divided into 32. So 4 octets, and each octet is made up of 8. So you have 8 bits here. Now, guys, what happens is, do we remember that in how a unit measured in computers? So it starts with a bit. So in computer, it is a bit is one value in which you can have only two numbers. Either it can be one or it can be zero. So it's either it can be one or it can be zero. So guys, here each bit has a value. So which means in computers, computer understand only binary language. This is what is known as binary. Binary binary language. No, machine language is different. Binary language. In binary language, there are only two digits, 0 or 1. The language that we use in our normal, it is called decimal language. Do we know this? From here. So the language that the numbers that we use in our real life, that numbering is known as decimal. And decimal numbering has 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So is around these numbers. So when after 9 it starts with 1 and then 0, 1, 2, 3, 4, 5, 6. And after that it starts with 2, 1, 2, 3, 4, 5, 6. So the numbering that we do in our normal life is decimal. But guys, knows only one type of numbering system, and that numbering system is binary. Binary system, and binary has just two values, 0 or 1. Now there is a third numbering system. There is a third numbering system that is known as hexadecimal. So this is binary. So this one is binary, and this one is decimal. So decimal normally decimal number. Right. So what type of numbering system is this? Is it binary or decimal? Decimal. It is decimal. It is decimal. But now your question is, Qasim's question is, or asking question is, yes, your question is that I am saying that computer understands only binary language, but why is it in decimal number? Why is it this number in decimal? If this number, if computer only, if this server understands binary language, why this number is in decimal? Guys, the reason is that this is easier to remember for us. But the computer has to convert it into binary when it works with it. So now going back here. So computer understands these type of numbering system. It understands decimal system. It understands binary system, and there is just one that is known as hexadecimal. Hexadecimal. So hexadecimal is very simple. It is 0, 1, 2, 4, 5, 6, 7, 8, 9. And after 9, it needs to go to, so hex. Hex means, what is the meaning of hex? What is the meaning of decimal? These are 10 in number. Binary means it is 5 means 2. It is decimal means 10. Hex means 6. So it has to be yes. It has to be. So now in order to make it 16, how do you make it 16? In our normal life, if you start adding, so here if I add 10, 11, 12, 13, this won't make sense because you're using the same number. You have to have unique number. Then in hexadecimal, what happens? After 9, it starts with A, B, and F. So now this is also part of our numbering system. That's why it is known as, so now if you count them 1, 2, 3, 4, 5, 10, 11, 12, 13, 14. This is the total 16 numbers. That's why it is known as hexadecimal. So guys, here, your IPv6 numbers are in hexadecimal IP address. IPv4 is in decimal numbering. When we write IPv4 address, so here, I'm gonna come back to your question. So here, you need to remember just one thing here, that IPv4 IP addresses, because I need this date, I'm gonna write it. So IPv4 address is made up of decimal number. Decimal number. Whereas IPv6 address is made up of hexadecimal numbers. Address is also hexadecimal, yes. It is hexadecimal. Hexadecimal. So this is made up of hexadecimal, this is made up of decimal number. Now why am I saying decimal number? Because this is a decimal number. This is a decimal. Now, if I can show you both type of IP addresses. So if I can go on to one of the servers here, if I can go on to one of the servers, and within one of the servers, what I'll do is I'll clear screen, and I would say IP config. So when you do IP config, actually, you know what? It's better to show you on my host machine because we have disabled IPv6 on servers. Here, here. Here you see? Where's the thing? Here, here you see IPv4 address, all decimal numbers. You won't find ABCD here. But if you look at IPv6 address, it has FE80, then 9F9A54. So this is hexadecimal. This is how hexadecimal is written. So this is why it is said IPv6 addresses are written in hexadecimal numbering. So for now, I'm just showing you. Don't think about how is it made and the complexity. Just for now, observe that IPv4 address does not have any of these A, B, C, D, E, F. So this is why it is known as decimal numbers, and this one is all hexadecimal number. So this is how it is written. But now there is a reason why IPv6 is in hexadecimal and why the other IPv4 is decimal. Question? The percentage, yes, I'm going to go through that once we start working on IPv6. I'm going to go through that. So guys, this is the difference of, so IPv4 is a decimal address, whereas IPv6 is hexadecimal address. Now guys, going back here again, IP address is a unique number assigned to all network devices. So what is it? Can we say that, please? Thank you. And artist, just you. Unique number assigned to all network devices. Guys, if you're not using our energies, I know we don't have energies to start with, but if I have energy, you have energy too. So we need to have that energy level. Because guys, the numbering that I'm going to go into now here, you need a lot of stamina and energy here. So, is this understandable? Yes, so far it is understandable. IP addresses are of two types, IPv4 and IPv4 is an older technology, IPv6 is a newer technology. IPv4 is a 32-bit address, whereas IPv6 is a 128-bit address. And here, IPv4 are written in decimal numbers, whereas IPv6 are written in hexadecimal numbers. And just for our photo memory, how IPv4 addresses are written and how IPv6 addresses are written. Okay. And now IPv4 addresses are divided into 4 parts, and each part is known as octet. So from now on, I know that octet is a new word for all of us, but now remember, octet is just that one part before the decimal sign. So it is octet 1, octet 2, octet 3, and octet 4. So here it has 4 octets, and each octet has 8 bits, which makes up the 32-bit address. So which makes up the 32-bit address. Now let's go into more detail. Is there any meaning for these numbers, or is there any meaning for these bits? Yes, guys, there is a meaning for each and every bit inside this octet. So let's try to find out the meaning. Guys, in order to find out the meaning of this, what we do is, since it is a binary language, there is a value for each number. Now, this complete number 192 is derived from binary number. So here we need to understand that this is just a simple conversion. This is just a simple conversion. This is just a simple conversion between binary to decimal and decimal to binary. So binary to decimal. So here it is 8 bits that are divided. So first of all, let's see how can you divide this number into binary number. So let me switch it off first. 7,000 emails? Okay. So, now, in this complete chapter, I mean, this one slide is explaining IP address. But guys, here I want you to have a very strong understanding of IP addressing here. So I'm going to go into more details than this. So here, IPv4 address, 32-bit address, it has 4 octets. Each octet has 8 bits. Now each octet is 8 bits. Guys, now let's convert this complete number into a decimal number. Why do we need to convert in decimal number? Because these all IP address that we understand is all in decimal number. So this is in decimal number. We need to convert. So computer, what it does? So computer works like this. So here you have computer 1 that needs to connect to computer 2. So this is Windows 7. This is Windows 7. And here the IP address is 192.168. So I'm going to write it here, 192.168, 100 dot, let's say 199. And here it is 192.168, 100 dot, 20. And they are both connected to internet. They're both connected to network here. Now guys, once this computer, you're sitting on this computer, and from this computer you want to copy a file on this computer. All you need to do is, you would connect to this computer, you would create a file, and you would send this file to this computer, right? I mean, now your question is, how do you send a file? Guys, it's just like sending an email to another person. So this is one example. Second example is, I'm going to come back to this example to make it more simpler. So let's say you're sitting at home. You're sitting at home. You have opened your Gmail account, and you're trying to send out an email. You're trying to send out an email to your friend who's sitting in Pakistan somewhere or some other country. So the email has to go from here to a Gmail server first. So it goes to a Gmail server. From here, Gmail server will decide where it needs to go to. Is this understandable? Yes. So you created an email, you sent it, you press send, and it went to internet, it went to Gmail server. Now guys, Gmail server has some IP address, and your machine also has some IP address. Let's say your IP address is 100.10, and here the IP address, I'm not writing the complete address just for simplicity, and here the IP address is 88. Guys, in reality, in what? In reality, how computer understand, Mubashir, how computers understand is, computer doesn't understand decimal number. So what it does, that as soon as you send this, computer right at the network card level, it will convert this decimal value to binary value. So first of all, it will convert this value to a binary value. In the same manner, when this computer tries to connect to this computer, now here it says the file needs to go to 192.168.100.20 from 199. From here, the file needs to go here. The computer will automatically first change into a binary value. So let's say I'm just giving just for example, I'm just using the random number. So it will be converted into this form, and then only your network is able to understand that which address it needs to go to. Yes, encrypt or decrypt. So those things. So guys, here, this number has to be converted. So going on this slow, a bit slow. I'm going on this a bit slow. So this computer needed to send some files to this, and the destination address is this. This is a destination address. Guys, computer doesn't understand decimal language. So what it does, here, right on, so this is who is converting it? Network card. Yes. This is all happening on network card level. So on network card level, it will first convert this address to this number, and then it is sent on the network. So here, and then what happens, there is a complete IP packet. Do we know what is IP packet? IP packet is that packet that travels on that network. So it travels between, later on we'll go into IP packet, but for now I'm just giving you an example. This, in order to deliver this file to this machine, this computer, the network needs to know the address. So guys, network doesn't understand. So just like no communication without IP address, do we know that? same manner, network doesn't understand decimal numbers. Network only understands binary numbers. So every time when two computers try to connect to each other, it will convert this number into binary number, and then only the switch understand, okay, this binary number is actually this person. Very good. So humans understand decimal numbers and computer understands. Guys, is this understandable? So guys, this is why we need to understand binary to decimal conversion. Now, before moving further, before going on to this, let's completely convert these bits into binary. So in order to convert this into binary, all you need to do, there are hundreds of different ways to convert binary to decimal. So here, yes, it is a job of network card, but for us, we need to have that understanding. Why? Because when you subnet the network, when we work on later on DHCP, we need to have that understanding. And more than this, for exam purposes as well. Because in exams, you will have at least 6 or 7 questions just on this conversion. So we need to understand that how it is all converted. So here. Now, so first of all, I am going to convert 8 bits into a decimal number. So this is a binary number. This is binary. I need to convert into a decimal value. And there are many different ways to do it. So the simplest way is this. So first of all, just look at the screen and then you can do it on your computer. Guys, I'm going to open a calculator, and within a calculator, I'm going to change it to scientific. And as soon as you change it to scientific, actually not scientific, programmer, within programmer, here it says binary. So this is binary, this is decimal, this is hexadecimal. So here I would select binary, and within binary, guys, as you can see, as soon as I select binary, the only two digits that are visible are these two. You cannot even select anything here. Why? Because in binary they don't exist. So now since it is binary, I need to enter how many bits? 8 bits. So I would enter 1, 2, 3, 4, 5, 6, 7, 8. 8. And in order to convert it, all you need to do is select decimal. As soon as you select decimal, this is a decimal value of this number. So I would say this number is 255. And this is the maximum number it can get to. It cannot be more than 255. It cannot be more than 2. So this is why it is said right here. It can only be between 0 and 255. It cannot be more than 255. Why? Because the total complete value of this number is only 255. It cannot be more than this. Now, guys, now convert this complete number into binary. So how would you convert it? On your host machine, you would open Internet Explorer, write this number on a paper, and then convert so this one and write the decimal binary value. Convert this one, convert. Now, all you need to do is the opposite of what we did. So here I would select decimal and then write 192. So write 192 and then select binary. So this is a binary value of 192. So here I would say this is 110 and 000. So this is how it is done. Guys, convert this complete IP address into binary. So, so now type this one. Okay, so the complete number here, one by one. Right under 192, I want to see what is the binary value, then dot sign, then dot, then second value binary number, third value binary number dot, I need to see it as an IP address. What? 8 bits, so add it on the left side. Now, in order to 0 1 0 1, convert it back to the real number. Hmm? Exactly, exactly. Just now these are 4, I need to see 8. 10 is this, but here it should be 8 bits. So in order to complete 8 bits, add 4 zeros before 1010. So that we need to fill up 8 bits. Just put zeros. But if nothing is there, it means zeros are there. But I want you to. Okay, okay, so that's fine. That's fine. It was converted, so it means it all. But here, IP address here, so let's write this number here. So here, let's say this one, if I convert this number, it will be 255. This will also be 255. This will also be 255. This will also be 255. Now let me write my IP address and then write the number here. So here my IP address is 192.168.100. So now let's write the number. So first one is 11000000. And second one 10101. And next one 1100100. And here, so here 1010. But just to write like that. 1, 2, 3, 4, 5, 6, 7. This is what computer does. This is what computer does. Computer always converts that. But now the big question is, why do we need to know that? Because if computer is doing all that in the background, why do we need it? Guys, we need to know it because now we need to understand that how these IP addresses are made and how many IP addresses can fit in based on what number we have. So here, IP addresses are of two types. Number one, IPv4, second one, IPv6. IPv4 is older technology, still in use. IPv6 is newer technology, will be used in future, or some places it is started being in use. IPv6, IPv4 addresses is a 32-bit address space, whereas IPv6 is 128-bit address space. Here it has 4 octets. Guys, IPv6 has 8 octets. It has eight parts. But later on we're gonna go into that. Don't go into that for now. And 4 octet, each octet is made up of 8 bits. So this is why it is known as 8 bits. Now guys, let's see what is the significance of these 32 bits. What is the significance of 32 bits? Guys, each IP address is made up of these numbers. So basically, if somebody asks us that how many total IP addresses that can I get from a 32-bit address? How many total IP addresses in the world can we get from a 32-bit address? It's very easy. How do you find that out? All you need to do is to take all the 32 bits, all 32 bits, and then multiply it into 2. So we'll take it like this. If we find the value of this, 2 raised to the power 32, why is 2? Because it's binary value. So 2 raised to the power 2, whatever the figure you get, this will be total number of IP addresses we can use within this scheme. So if you find that out, and how can we find that out? So again, from the calculator, let's find that value. So in order to find that out, so here all we need to do is, what is it? How much is it? So it is power. So guys, you need to change into scientific calculator, and within scientific calculator we'll take 2. So since you're taking 2, and then you need to press x raised to the power y, just click this and then type the value 32. And then you would click next, and this is what you have from 2 raised to the power 32. So this is around 4.2 billion IP addresses. 4.2 billion. No, complete. If you're able to use 32 bits, complete 32 bits for IP address, you can get this number of IP addresses from this scheme. Yes, they are in use. They are in use. So guys, here, this is a total number of IP addresses that can be used. Okay, so right here, one more time. I'm gonna do the calculation one more time here. So all you need to do, press 2, and then use this x raised to the power y, and then as soon as you do this, and then use 32, so then it gives you 4.2 billion. Okay, 4.2 billion. Now let's see. Huh? Sorry? What is 2? 2 is the numbering system. It is the numbering system. This complete numbering system is binary, so this is why 2 raised to the power 32. Now, why am I saying this? Why am I saying this? That 32. Guys, it is exactly like this. It is exactly like this. That how many IP addresses can be made up from these numbers? How many IP addresses can be made up? For example, if it would have been only 8 bits, for example, if it would have been only, so for example, if it would have been only, let's say, 2 raised to the power 8, that could be 2 raised to the power 8. So here, if, let's say, if this numbering system, the complete numbering system on the IP address was based on just 4 bits, IP address was made on 4 bits. So that could be 2 raised to the power 4, and 2 raised to the power 4 is 16. It is 16. So total 16 IP addresses you can have if you have this, if you have 4 bits in an IP address. So total bits that we have is 32. Now guys, let's quickly go back into history and when it was started. Guys, early 90s when they discovered this system. Actually, in mid-80s, they discovered this system, IPv4 system, and they started making out IP addresses. When they made the system, at that time, they calculated and they thought that 4.2 billion is a huge number of IP addresses. Guys, keep that in mind. In mid-80s, there was no internet. There was no internet, and internet started in late 90s. So here at that time they said, oh, you know what, 4.2 billion is excellent number and it will never finish based on what they had at that time. But guys, time goes on and on and on, and mid-90s they saw that, you know what, 80% of IP addresses were used in mid-90s, 96, 98, 90. At that time they started thinking, you know what, this 4.2 billion is nothing. Now the big question is, where were all these 4.2 billion IP address went? Guys, since we know that no communication without IP addresses, right? So now think of this internet. Think of this internet here, and internet and all the devices that are communicating. Device has to have a. So let's say, let's look at the most well-known servers. So the most well-known servers, let's say Microsoft.com. Microsoft.com, it has IP address. Now, Microsoft does not have one IP address. Microsoft has a stack of IP addresses. But Microsoft has a huge number of services. So just like Microsoft, let's say they are using, let's say, 100,000 IP addresses. And then you have Yahoo. And then you have Gmail. And then you have MSN. And then you have all other websites. Guys, these all come in. And now at this point, these IP addresses are near capacity. So from 96 on, they started thinking of having IP addressing. At that time, there were many suggestions on the table and many different ways to have different number of IP addresses. But guys, at the end, after all discussion, this was selected. And then they said, okay, first of all, in this, we're going to have 128 bits instead of 32 bits. Now we can calculate that how many IP addresses can accommodate in 128 bits. So, sorry? Uh, each, each will be 16 bits. 16 bits. Yes. So I'm going to go into that how it is divided. But for now, just remember they came up with 128-bit scheme. Guys, 128-bit scheme, you cannot even calculate it on a calculator. Calculator has to go into a plus and e sign. So if you try to do it, let's try to do it here. So here, 2 raised to the power 128. And 2 raised to the power 128 is not. Some documents says it's an infinite number of IP addresses, but it's not infinite, but it's a huge number of IP addresses. Yes. Okay, just 2 more minutes, 3 more, 5 more minutes. Just few minutes. So guys, here, do we understand this? Do we understand this? Here, IP addresses of how many types? 2 types. 2 types. IPv4 and IPv6. And IPv4 is older technology, 32-bit. Guys, now we know what was the reason why we had to come up with a new IP? And the reason was lack of IP addresses in this. Lack of IP address. So we have less number of IP addresses here, which is almost accumulated now in the world. So this is why they come up with this scheme, and this scheme is not operational throughout the world. Japan started using this scheme throughout their country. They are using IPv6 addresses. Singapore is using IPv6 addresses. China, half China, North America, no. North America, everywhere it is only decimal addresses. Only IPv4 IP addresses are in use. There are many advantages of IPv6, but guys, in order to have IPv6 within the environment, you have to have a complete infrastructure. You have to change your switches, you have to change your routers, you have to change the complete. It's a huge big change when you move from IPv4 to IPv6. So the companies, how they go about it, is they want to implement IPv6, if they want to implement, what they do is they start from a very small part of the network. You can communicate, but you have to have It's not a simple upgrade. So for that reason, North America here, even in Middle East, it's not being in use. Just few countries of the world, but in future it will be all IPv6. Yes. Maybe your kids, when they'll be studying in fast track, they might be studying only IPv6 because it has to go over there. Now, so guys, right here, we'll take a quick break, and right after the break, we'll start on IP address. Let's take a break, yes. 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 No, no. Okay. Okay. So here, IP addresses, we started working with IP addresses. IP addresses are two types. Here, IPv4 32-bit address. 32-bit address first time was introduced in mid-80s. They started thinking of IP addresses. Why? Because networks doesn't work without right? Do we understand the basis of IP address now? IP address was required for devices to work on a network. Now, at that time, they came up with 32-bit scheme, but when they calculated at that time, it was around 4.2 billion IP addresses, but now it's all, they are mostly, for that, in mid-90s, they started thinking of this scheme, or there were many other schemes on table, but this was the one that was selected. And now we know if you calculate the number of IP addresses that you can get with this, it's a huge amount of IP addresses. Now, guys, so let's go back to 32-bit address scheme. 32-bit address scheme is 32-bit address scheme. It has four parts when you write an IP address, and then when you write that IP address, guys, let's relate it to what we already know. So, in a computer, when you install an operating system, and when you go to the network called TCP/IP service, then you set up IP address. Is that correct? So we do go into. So do we remember setting up IP address in a server? Yes. So what are the things that we see in a network card where IP address is required? So if you go to the TCP/IP section, it asks for number one IP, and right under this it asks for subnet mask, and right under this it asks for a gateway, and right under this it asks for DNS. And DNS has two methods. It has a preferred DNS and alternate DNS. So, so it is like this. Now, since at that time when they decided IP addressing, Windows also made their operating system where to set up the IP address. So you have now a server, and then in this you set up IP address. You install the server, set up IP address, install Windows 7, set up IP address. As soon as they are set up, they start working together because this is how. And then when this computer needs to connect to this other computer, this computer needs to connect to here. Do we know Moit? Where is Moit? Okay. Okay. And Bilal sent a message. Who else is missing? Oh, Shafa. Okay. Guys, next time remember, please send a message if you're being late, or if you're. I just. So it's better to. Now, guys, since at that time when they decided that IT address has to work together, now the next challenge was how to use them in the network. Now, in order to use them in network, first of all, they decide. So now think of this. We have now 4 billion IP addresses to work with. Now we have 4 billion IP addresses. How can we effectively use them? So one way of using them was that okay. So we'll start with one IP address. Your one IP address could be 1.1.1.1, and your last IP address is 255.255.255. I mean, it could be like this as well. Just and the second iterable, so it could be 1.1.1.2 and then 1.1.1.3, and it can go on 1, 2, 3. So this was one way of doing it. But guys, it has to have a more systematic way. Now that in order to go into that systematic way, we don't want to go into huge things here, but the thing that we need to remember that how these IP addresses work in different type of networks. So, okay. So first of all, now we have found our IP addressing. Now the second thing, how can we work with them? Guys, in order to work with them, what they did, just like IP address is divided into two, IPv4 and IPv6, exactly the same way, networks are divided into two. So all types of networks. One is a network. A network is just where computers are connected together. And they said the network overall are divided into two types of networks. One is private networks, and the second one is public networks. So public network and private network. Public network, guys. Public network is a very easy to understand. Actually, both are very easy to understand. Public network is the complete network that exists on the internet. Over the internet, everything that is on the internet is known as public network. So this says public network is said to be as the internet. So on the internet, this is public network. Private network is said to be inside the organization that you have a network that is known as a private network. So private network is known to be like a home network. Home, it is also known as intranet as well. So private network can be your home network. Private network can be a small company network, a small company network, or private network can be a medium or large company network. So here. So networks are divided into so on broad level they're just divided into public networks and private networks. Which means if we go into examples, our home network that the where we use our internet. So as soon as I enter my house or even near in the parking area, as soon as I go there, my Wi-Fi automatically connects. It means that it is part of my home network. So on at home, we are all using networks. Small companies are all using networks. For example is Canuck. Example is a small clinics. Example is small law firms and all those. And medium to large size companies is Rogers, Dell. So it's not Dell, it's Bell. You made me note that. Okay, so Dell. Yes. So yes, small company. So guys, which means now we have to have this very good understanding, and it's very easy to remember. Networks are of how many types? Two types. There is private network. There is public network. Guys, private network is everything that is inside of some premises. It is inside this unit. It's a private network. It is inside Rogers' company for employees, and it is a private network. And this is a public network is everything. So do you think these are all public networks? Yes. So which means all Gmail servers are public network servers. So here, for example, as an example, we need to remember public network includes Gmail, Gmail network, complete Gmail network. Then you have Yahoo. Yahoo is complete public. Microsoft, Microsoft, MSN, and everything that exists on network. Urdu News, and ptv.com.pk, YouTube, everything is on internet. So this is all public network. So now guys, we have divided networks into private and I'm hungry. Don't, no, please, please. I mean, the word browse at this moment. So what was you saying? Broadcast. Broadcast. Yeah, broadcasting is also a difference. So guys, again, let's go here. Let's go here. 1 hour 20 minutes. Yes. So here's that network, private, public, and public. So guys, they first of all they divided into this. Now, as soon as they divided into two types of network, guys, they also divided the IP categories into these networks. So they said, you know what? So there are two types of network. If I need to apply a network, if I need to apply some sort of IP addressing, so first of all, just remember that the networks are of two types, private and public. So here, do we remember this? Private and public. Do we understand a clear boundary line between both of them? Public is all internet and private is all somewhere in your home, in a small company, in a large company. Now the next thing that we need to understand, so first of all, in order to apply this IP schemes in networks, the very first thing they said for private and public networks. Now the second thing they did, they divided the IPs into different type of classes. They divided the IPs into different type of classes. So what are different type of classes? Guys, exactly like when we travel, why do they divide people in that? So you have E-class, have a business class, and there used to be, if you remember, economy plus class. Why do they divide these? Based on whoever has more money. And this is their criteria. Whoever can pay 3 times normal ticket, he can travel in business class, right? IP addresses are divided into 5 classes. IP addresses are divided into 5 classes. Now here they call it class A IP address, class B IP address, class C IP address, and class D and E. Why do they divide the IP addresses? Why? Because guys, they have divided networks into many forms, but then again, in private, there are many different type of companies. For example, there are very small, there are places that needs a very small number of IP addresses. Then there are companies that are mid-sized companies. Then there are large companies that need IP addressing. So just based on the size of the networks inside, they said, okay, you can use these number of these classes. Now, class A IP addresses, all class A IP addresses. Now, this is you can remember that these classes are based on the size of the network. Now, size of the network. So, anybody knows what are these classes and where do they start from? Where do they end? Yes. Class A starts from 1 to 127. Actually, 126. So, okay, 1 to 126 and then class B, 128 to what? 191, yes. 192 to 220, 23, it is 223. And then here it is 224 to onward. So let's remember first these 3 classes. So first of all, these are IP classes. Now, let me try to relate it to what we know already. Okay. So first of all, do we remember that IP addresses is a 32-bit address? Yes or no? Yes, sir. Yes, number one. Number two, do we remember that IPv4 address has 4 octets? Yes, yes, it has 4 octets. And each octet has 8 bits. Now, so remember when I was saying that now I need to apply this IP address key. So what I can do, the simplest form would have been, if these calculations are completely omitted, the simplest form would have been for this machine, let me give an IP address of 1.1.1. So this could be my first IP address. 8 are all based on the first number. So any IP address that starts from 1 and goes to 126, this is known to be class A IP address. This is known as class A IP address. And any IP address that starts from 128 and goes on to 191, this is known as class B IP address. So all class A IP addresses, they start from 1 to 126. All class D, so this is only talking about the first octet, guys. Other numbers are not used. So if the first octet is from 1 to 126, it is class A IP address. If the octet is from 128 to 191, it is class B IP address. So just this. It's okay for you? Okay, it's fine. And so next time you guys sit here. So here guys. Okay, let's try to understand it. Is this understandable? I mean, this is very easy. So if the first octet is 1 to 126, it is class A. If the first octet is 1 to 128 to 191, it is class B. And if the third octet is 192 to 223, this is class C. Now, how do they further divide it? Guys, further they said that if it is class E, class B, class C, let's limit the number of IP addresses. So what they did, what they said, you know what? This will be the IP address, and their subnet mask. Their subnet mask will be from 255.0.0.0, and subnet mask of class B will always be 255.255.0.0, and subnet mask of class C will be 255.255.255.0. So why they said that? So we just need to remember this. Now here, let's remember here. Guys, what is the subnet mask we use on this server? What is the subnet mask? 255.255.255.0. But before even going on to subnet mask, what class of IP address is this? This is a class C IP address. So this is a class C IP address. So any IP address. Now guys, go onto your host machine and find out the IP address of google.com. So if I go onto host machine and just go onto CMD, on your host machine, open CMD. Open command prompt on your host machine, and then just say ping google.com. As soon as you say google.com, so you have to do www.google.com. What? You got it without that. Okay, that's fine. In my case, it went through. So here, are you able to ping it? So open command prompt. Okay. Uh, just don't say continuous. So open CMD. You're able to do it. Okay. Yes. www.google.com. Yahoo. .com. So now the IP address starts from 1.194.200. What class is this? Let's see the classes. It's class A. Yes. What class is that? Okay. So now, guys, let's analyze this experiment. So what we did, we tried to find out the IP address of yes, I'm gonna go through why subnet mask and why it is there. So here, guys. So here. Now here, class A, class B, class C. Now, based on whatever company has bought, in my case, let's see here. Google is showing me 173 IP address. In some of your machines, it is starting with 74 IP address. Guys, since Google is a huge big company, they don't have just one server serving all of us. They have actually 20 or 15 or maybe more servers for just this region. And then for each country, they have many different number of servers. So now I want to show you is that these companies they have many different number of IP addresses. Now now here, so IP addresses are divided into classes: class A, class B, class C. And then, guys, these both classes are experimental classes. These are These are experimental class. They are not used in the real network. They are experimental class. Um, so, so, so they don't have much significance here. But this one, yes, we do need to remember this is class A, class B, and class C. Now, guys, these same addresses are used. These both classes exist in private or public network. Now, this is said to be in public network. So, if I can write here, class A, class B, and class C, and here also class A, class B, and class C. So class A, basically these numbers are for public network. So whenever somebody needs an IP address in a public network, they will be offered IP addresses from these tags. So here I can go 128, 191, 192, and 223. And guys, on the private side, we are limited with number of IP addresses. So for private side, class A range starts from, it has only one range that is given, and that one range is 10.0.0.0. Is that true? So 10.0.0.0. Nasrullah here, he has many network certifications. So I cannot go wrong here. so, uh, so here 10.0.0.0. And here class B starts from 172, 168.0.0. And here class C is 192, 168.0, 168 dot, I think 16 is not. Yes, and here this is 0.0. So this is how it is, 172.16.0.0. So now here, the one common thing, question? These are private IPs, these are public IPs. I'm going to go into, again, I'm going to repeat it. So since it is so much information, I know that for most of you it's not very clear, but guys, before even going into this, guys, this all analysis, is mostly being done by the network team. We don't make it. So if you're working for Rogers, if you're working for Dell, if you're working for network team that needs to find out which aspect in our network. But being on the system side, we need to know at least this. There is huge detail more than this. There are more details. But this book in this chapter, and our field does not require that much detail. But we need to remember this. So again, IP address are of two types, IPv4, IPv6. IPv4 is a 32-bit address, and since being 32-bit address, it has a limited number of IP addresses. And at that time, when they had a limited number of IP addresses, they thought of, in mid-90s, they saw, oh, IP addresses are vanishing. How did they know IP addresses are vanishing? Because guys, let's say in 86 or and so on, they saw that 2.4 billion IP addresses. Then companies started getting IP addresses. So there is a huge big organization called Internet or IANA or whatever organization. So these companies, for example, this company, they needed a website. They went to this organization. They said, we need two IP addresses. They said, okay, for two IP addresses, this is $100 per month a cost. At that time, it was very expensive. So $100, they said, okay, two IP addresses given to this. Then four IP addresses given to another one. Then and so on, and so on, and so on, and so on, and so on. About the universe, not universe. People started getting IP addresses, and this 4.2 billion went down to 1 billion, and from 1 billion, it now went down to into 100,000 or something. I don't know the exact, and we don't care about how much numbers are, but the main thing is we need to understand why this happened. So at that time, they started thinking of, oh, you know what, 4.2 billion is finishing. So at that time, they introduced IPv6. IPv6 gives us more IP addresses. But during this time, when they were doing all this, they introduced classes of IP addresses. Now, classes of IP addresses is class A, class B, class C. Any IP address that starts from 1 to 126, it is class A. Any IP address that class starts from 128 to 191, it is class B. And any IP address that starts from 192 to 223 is class C IP address. Now, why are there are classes here? Guys, there are classes in all these, so I'm going to come back to here. Here, the one common thing in both of them, the one common thing, as you can see, it is different in IP addressing. But one common thing in both of them is their subnet mask. The subnet mask of class A is 255.0.0.0. And here it is also 255.0.0.0. Here, subnet mask of class B is also 255.255.0, and here it is 255.255.0.0. And here, subnet mask is 255.255.255.0, and class C is 255.255.255.0. So one common thing in both of them is their subnet mask. Yes. So you're right, but here this is actually part of a private network. Here it won't be used here. So it can use 1 to 9, and then it starts from 11, but somehow it is included in this. So in books, in all documentation, you would find this number. Okay, but so here guys, subnet mask. Now let's understand what is subnet mask and why subnet mask is there. Because we do understand the numbers here, that it is just a classification of this. Guys, now subnet mask is there. Yes, I'm going to explain that why. Because class C on both sides, here it starts from 192 and here it starts from 192 and 223. Just one range within 192 is this, and that is dedicated to a private network. So in few minutes, this will all be clear. This will all be clear. So let's first understand this. So what is subnet mask? Subnet mask. What is subnet mask? Now, keeping in mind while I am explaining subnet mask, we need to remember that networks are divided into two, private network and public network. Private networks are whatever is in the premises In local network, it is known as private network, and public network are whatever is on the internet. This is all known as public network. And in order to better manage these IP addresses, they are divided into class A, class B, and class C. And few moments you will remember, it will be understandable why they are divided into different classes. Although the classes are there for a reason. The classes are there for a reason. Exactly the way economy class, business class, or first class. So they are there for a reason. And here, classes are just not for to divide numbers. No, there is a reason why they are like that. And now I'm going to find out what is that reason. Guys, the reason is, so the reason is that each IP address has two parts. Each IP address has two parts. So so we are finding out what is subnet mask. So in order to understand subnet mask, we need to understand IP address. So IP address. IP address is divided into two parts. So here, let's say this is my IP address, 192.168.100.10. This is my IP address. Now, this IP address is divided into two parts. There is a part that is known as a network address, and this part is known as host address. A network address and host address. And all these IP addresses are divided into network address or host address. So some octets are part of network address and some octets are part of host address. Now the first thing you need to understand why IP address is divided into network address and host address. Guys, the reason they are divided into network address and host address in order to find out where the IP exists. Now, in order to understand this, guys, we all are using this type of separation in our real life. For example, if I need to go to, if you need to come to Canucks here, the Canucks address is 120 Matheson East. It is 120 Matheson East, and it says unit 20, right? So anybody who needs to come to Canucks, first they need to go here, and then they can reach here. So this is actually the network address, and this is actually a host address. Exactly like this, in IP address, if I'm saying these three parts is a network address, it means this is a complete network. This complete network has this in common. This is the network address, and each host has a different number. So this number will be changing, and these numbers will never change. Exactly the way in address, this number will never change whoever needs to come here, but unit can change. I can move from this unit to another unit. So unit can change, but this will be never change. Exactly in this manner, guys, in this case, this number will be same for all servers. Now, I'll come back to your question in a moment. If you can see on this, in our example, the example that we are using here, you can see this first three letters are common for all of them. Remember? So these common letters, this is the network address of all these servers. So this is the network address. And what is different? The host address is different. So each host has a unique number. This is known as host address. So this is host, and this is network. So network and host address defines where is the PC that I need to reach. So question? Yes. Okay, no, the DNS is a little different topic. So, but for now, just remember IP address. But IP address is all like this, right? So now, guys, let's understand what is net. So for now, we do understand network address and host address just separates where the network is. Now, this can be better understood if we have two networks. So let's make two networks. For example, if you have a building and building has three floors, so floor one and floor two, and on each floor you have some number of PCs. So you have, let's say, some computers sitting here on this floor, and some computers sitting here on this floor, and some computers sitting here on this floor. Now, when we network them, they have to be connected to this network. So this is connected to this network, and this is connected here, and these are connected on this network. So these are three separate networks, guys. Guys, if they are three separate networks, they have to have different IP addresses. So, everybody is with me here? Yes or no? Three, net, three different networks. Exactly. So here, guys, here, now this is our network. This is our normal network, which is this network. Our normal network, which is. So I'm going to create IP. So for this one, the IP address will be 192.168.100 dot, let's say 11. And this one will be 192.168.100 dot 12. And so on and on I can. But guys, on my second floor, I have to have a different network. So network will be 168. Instead of 100, this will be 101. This will be 101 dot 10. And the second machine will be 100 dot 1, 192, 101 dot 12. And on this, network has to be different. So here you can have 192, 168, 100, 2 dot. So now guys, so here it is more clear that why do we have separation in IP address? Now let's say this machine needs to send something to this machine. As soon as this machine needs to send something to this machine, guys, the switch between them, the routers between them, they need to know where do you need to send this packet. So in that case, the routers automatically, these routers are automatically are aware of this thing. So first of all, what they do, they take the IP address. For example, for this one, destination IP address is this. So it needs to send something to this address. So what this does, as soon as it receives the packet, it says, so let's say this is a packet, that this needs to be delivered to this machine. As soon as it is reached to a router, what router does, guys, because these are all machines, they work in systematic. So this would do, first of all, it would divide the network address to, it would say, what is my network address and what is my host address? Exactly in this manner. For example, the first time when you had to come here, you asked that what is your address? And then I said, my address is 120 Matheson. Then when you were coming here, did you first were you first looking for host or the street address? Street. You have to reach to a street that exactly in the same manner. When this machine, when this router needs to deliver this packet, it says, okay, let me first find out what is your network address. So as soon as it says, oh, this network address is on floor one, so first, and then it finds out that it has to be on this host. So what it does, it will send the packet on the relative router. So there is a router on each floor. So here there is a router. So it says that I have a message for you, and it receives it, and now it needs to find out what is the host number. So when it says, okay, this is my network, and my PC is this, and this is how it works. So in short, the network address and host address is for routers to know how to and where to send the packet. Exactly for us, how we find out house addresses. So now going back onto this again one more time. We were trying to understand what is a subnet mask. Guys, subnet mask defines which part of your IP address is a network address and which part is the host address. Now, let's join these dots together. Let's join these dots together. Here. Now, let's say, this is a subnet mask. This one is a subnet mask. Guys, under any octet, if there is 255, under any octet, if there is 255, this octet become a network address. And in this case, in our case, in all these servers case, we have 255 under first three octets. And then here we have 0. It means as soon as router takes the IP address, it knows, oh, this is a network address, and this is a network address, and this is a network address, oh, this is a host address. So subnet mask here, if I say one liner for subnet mask defines the boundary between network address and host address. So subnet mask defines the boundary between network address and host address. That is the sole purpose of a subnet mask. That is the sole purpose. Subnet mask is only there for routers and for us, even for us to find out which one will be a network address and what is the host address. Now, let's see. So it will make sense in two more sense if it is not making it right now. So now, here as you can see, in class A IP address, the only network part of the address is the first octet. So this is only network. So let's write N on this. This is a network. Yes. And class B IP address, how many parts are network address? First two. So which means this is network and this is network and this is host and this is host. In this is host, this is host and this is host. And in the last C class, here I have this network and is this network or host? Why is it network? It is a decimal number, but why is it network? Because it's 255. So here, just put this under this. So you have 255 here, you have 255 here, which makes this a network address, and you have 255 here, which makes this a network address, and you have 0 here, so this is a host address. So guys, under any offset, when you see 255, it becomes a network address. Now let's come to $1 million question. Who will pay $1 million? So guys, which means a very important question. Guys, a very important question is, what is the significance of dividing network and host address? Guys, there is one more little very important thing. And one more little very important thing is, what? No. So, one more very little important thing is that this is all, they are also divided for a reason. They are also divided for a reason. So, before going on to that reason, do we understand what is a subnet mask? Subnet mask just divides which part of the IP address is network and which part is host. If subnet mask is not there, then guys, you cannot distinguish. For example, if this IP address is just written like this, so 192.168.100.10. If it is just written like this, guys, nobody can find out that where is my subnet mask. It could be a class A, it could be used as a class A, class B, class C. If there is no subnet mask, these routers, these switches, they won't be able to find out that, what type of IP address is there. Right. If we put 255 under this, it means that this is a network address. If we put 255 under this, it's network address. 255 under this, network address, and this is 0, this is a host address. Now, what? It won't even take the IP address. So let's look at this. It cannot be blind. It cannot be blind. So if I go into this here, right here, if you can see, in network adapter, if I go to here, if I go to properties, and if I go to here, if I go to, okay, this is actually assigned to the switch. Let me go to the other one. So here, yeah, it won't. Okay. So here, guys, look at this. Here, I can put in the IP address. Let me put an IP address for this. So let's say 192.168.100 dot something 166. But guys, here, if you go, it won't even move forward. Why? Because you must enter a subnet mask. You must. Why? Because no switch, no router, nobody will be able to understand what type of IP address is it. Now let's see. and here it's saying you have entered address that is missing a subnet mask. So please enter subnet. So here it automatically added a subnet mask for me. Why? Because it knows that 192 is a class C address. So let's say if I enter a class A IP address, let's see this. So here, so class A IP address starts from 10. If I say 10.0.0.0 and then press tab, it automatically brings the subnet mask of, so it automatically brings the subnet mask of this because it knows this is a class A address. So guys, subnet mask, what is the main purpose of subnet mask? It distinguishes between network address and host address. Now comes a very important question. Is there any other reason for these subnet masks? Yes guys, there is a very important reason. So here, look at this here. First of all, here, how did we find out? How did we find out that how many IP address can be used from this 32-bit range? All we did, we said, okay, 2 raised to the power 32, and whatever comes, this is 4.3 billion IP addresses. This is how we know how many. Guys, exactly in the same manner, we'll find out how many IP addresses can we get from each class. Let's say, for example, here, this is all network, and just the last one is used for host. So last one is, so let's look at this one. So 192 is network. I cannot take host IP addresses from here because this is network address. It will never change. Just like your home address won't change, but the unit can change. So here, this won't change, this won't change. The only thing that I have is this octet. And in this octet, how many total bits are there? Total bits are 8. What happened? Imran, are you working in the morning? Imran, why are you sick? Why are you sick? No, you're not sick. Imran. Huh? You need coffee? In Rosa? Okay. Imran, have a good sleep before coming here. Because I... He did? Imran, you could not say okay. So here guys. Don't have too much sleep. Have less sleep. So Imran, for everyone guys, whenever you feel sleepy, just walk around and because this is very important. Because as soon as you go into the nap mode, this is all gone. So it is very important. So guys here, I'm gonna make a very important point here. So guys, let's see. So here I have a network address, network. Whenever you have a network part or the simple idea is whenever you see 255 under any object, it can never be changed. Meaning it can never be assigned. So total number of bits, if I make a new one, okay. 192, 168, 100. Now this is a complete network part. A network part cannot be changed. The only thing that will change on all hosts is this last address. So this is why on this one it is 10, on this one it is 20, and on this one it is 50. The only thing that is changing is the last octet, right? Is that true? Now guys, in order to find out how many IP addresses can I have in this is by first of all, take all of the bits, take all of this. So total bits in this can be 8. 1, 2, 3, 4, 5, 6, 7, 8. And then you can find out the power of. So if you go with this, this will be converted into 255. 255. Did we not convert it? Yes, you're right. You're right. You're 100% right. Here, I know what your point is. I just want to show you what is 2 raised to the power 8. So here 2, x raised to the power y, and 8, and n. So total 256 IP addresses you can get from here. Total 256 IP addresses you can get here. So now guys, if you have a class C IP address, you cannot have more than 256 IP addresses. Why we have 0 here? 0 means here. Yeah, this is fine. This is fine. As long as, so even if you, let's say, even it would have been 100, but as long as under this 255, this will never change. So it doesn't even matter. So for now, just remember this is 0. Okay. So now, in class C, total number of IP addresses that you can get from your company. Total number of IP addresses is 256. You cannot get more than 256 IP address if you use a class C address. So which means class C is used for very small companies. Class C is used for small companies. So here you can say class C IP addresses are used for, so this is for small companies. It is used for small companies. Now let's say that you have a small company and now I need to register my computer. When I register my computer, I know that I have 3 different classes to work with. So I can use this class, I can use this class, or I can use this class. But the question here is that which class should I use? Technically, whichly? Not loosely. technically, technically, I should select class C. Technically, I should select class C because class C has 256. Let's say I only have 20 computers. Why should I use a different class? Now the question is, why should I not use this and why should I not use this? So guys, I'll give you a very simple answer. I'll give you a very simple answer. So let's say you're a manager. You're a manager in a company. Here. And then you have to manage some people. Let's say if you're a manager and you have to manage 6 people as opposed to a manager managing 60 people or as opposed to a manager managing 6,000 people. In all of the cases, you're getting the same salary. Here you're getting 100K and here you're getting 100K and here you're getting 100K. Which one would you prefer? Guys, less less people, more money is better, right? Here it becomes more complex. Guys, exactly the same way works in the networks as well. If you have a very small network and you go with this class, this with the management for switches and router becomes very difficult. So it is recommended that if you have a small network, just use class C. If you have a medium-sized network, just use class B. And if you have a large network, use class C. Now, what is the reason why I am saying this is for medium-sized organization? Very simple. Guys, in this case, how many parts are network? The first two. This is a network part. This is because the subnet mask here is 255.255. And the total number of host IP addresses I can have in this is 2 raised to the power 16. So I can, okay, okay. Abid, Abid, I'll ask you a question, then you'll reply. You know what? This is already very complex. And with your suggestion, what's happening is their graph of understanding is going like so I'll ask you. So here it's a very good that you have find it. How did you find it? Excellent. So guys, one more time here. One more time. Class C IP address. Do we understand how many IP addresses are in class C? 56 IP addresses. 256 IP addresses. Khubab, is this clear? Khubab. Raised to the power 8 bits, yeah. -2. I'm not going there for now. I get your point. Why I'm saying it, I just want to give them a simple understanding. And once we do subnetting, then I'll go into all that. I get your point. I just want to give them simple numbering. So guys, Nasrullah's point is that it shouldn't be 256, it should be 254. And the reason here is, since Nasrullah brought this up, because it's 254, because first and last IP address on any network are not used. So we won't ever use 0 and we will never use 255. So 255, so this is what -2, and later on once I do subnetting, I'll go into that point. For here, I just want to have simple understanding. So guys, networks are of how many types? Two types. Network is private network and public network. So what is first one? Private. Second one? Public. And the networks in real life, private network can be a home network, a very small company, a large company. Now guys, we can add all these dots. Since it's a home network, guys, that is why, since it is a home network, that is why in all our homes, all our IP addresses start from, they're all using this range. Even if you're getting the router from Rogers, getting a router from some other company, they're all using the same range. If you go home, your all IP addresses start from 192 and 168. Even your all smartphones get here, and we're using Bell and it is 192. And why is that? Because these are all very small networks. Your home network can never be bigger than 256 number, right? So this is why all the companies are using this scheme for the home private network. But when it comes to large networks, any network that is bigger than 256. So guys, the next range is class B address. And in class B address, how many IP addresses can accommodate? Just like Abid said, it's very simple. It is 2 raised to the power x and 16. And here it says that 65,000 IP addresses you can get from this network. What is the number? 53. So this was for a very small company. This is for medium-sized company, medium to large. And guys, class A IP addresses are used for large, ultra-large organizations. Which means that how many IP addresses can be accommodated in them? 2 raised to the power 24. 24, because first octet is network. First octet is network. So in this case, it has 16 lakhs. 16 lakhs, and this is for large organizations, large companies. So guys, now do we see the reason? So first of all, we started with IPv4, then we saw it is 32-bit address, so altogether 4.3 billion address. And then they thought of, let's make it more systematic, because if we start using from 1111 and 1111, 1112, 1113, 1114, 1115, then it doesn't make sense, because your all network is not in one place. Network is scattered all over the world. So it has to be some more way of doing it. At that time, they came up with classes of IP address. So they said, okay, let's divide it into class A address, class B address, class C. Class A will be used for large organizations. Which organizations? No, not large. Large organizations. What is that? Sakib, just you. No, large. Yes, guys, exactly how Sakib said it. Large organization. So guys, let's remember it. Class A is for large organization. Class B is for medium-sized organization. And Class C is for small organization. So this is why these classes are. And what do we learn about Class A, Class B, Class C? If we had 4.3 billion IP addresses, they said, okay, so 4.3 billion IP addresses. I have my home network, I have a public network. How can I divide that? So in doing that, they said, okay, let's fix some ranges for just private network and some ranges for public network. And at that time, they found out, you know what, public network is huge. So for public network, they said these all ranges are for public network, and just these three ranges. This three range of IP address is private network. So, so between this complete class, now this class is any IP address that starts from 1 to 126, it will be a class A address. So in this here, this is all for public networks. Who manages it? Internet. Internet manages it. If I need an IP address today, I would request a Bell. Bell. From here. So my point of contact is Bell. So I'm here. I need an IP address for my server. So I have a server that I need a dedicated IP address. I would go to Bell because this is what I know. I don't know who Internet is. So I would go to Bell, I would ask them, you know what, I need to buy one public IP address. So they would say, okay, one public IP address is $10 per month. And in some cases, you would find a public IP address for $4 per month as well. But then those are internet companies. But this is a reliable company. If anything goes wrong with the IP address, I can still go back to Bell and ask them. But here, when you buy from internet, there is less reliability as comparatively. So here I went to Bell, and what Bell does, Bell goes to national Canadian IP some company. So there will be a Canadian pool. So for each country there is a pool of IP addresses allocated to them. For China, they've allocated some IP addresses to them. For Europe, they've allocated. They don't need to go into their data. Thank you for the pool. So yes, guys. So here, on this side, guys, public side, the only thing we need to remember is that class A starts from 1 to 126. Class B starts from 128 to 191. Class C starts from 192 to 226. That's the only thing you need to remember. More than this, we don't manage it. We will never be able to submit it because this is all responsibility of this. As far as the private address is concerned, you need to remember all three classes. So there are three classes of IP address. Class A range starts from 10.0.0.0. And in this, what is the subnet mask for this, Imran? 255.0.0.0. What is the class B? Ahmed? 172.16.0.0. What is the subnet mask? 255.255.0.0. Mubashir, what is the IP address range for class C? And subnet mask? 255.255.255. Thank you. So here we need to remember that wherever 255 comes, that becomes a network address. So this is a network address, and this one is a host address. Now, wherever you have zeros, you can combine them and make them so. Combining them and get their power gives you the number of IP addresses they can use. In very simple, in very short understanding, class A are used for large organizations, class B are used for small organizations, and class C is used for very small organizations. And this is why, this is what? This is why our all home network starts from 192. This is why we in a class we are using class C and C. So some of you were asking me in class 1 that why we are using this IP address. So guys, the reason is we will never have more than 255 machines in our network, in our class network. Even combined together, we don't, and even in this machine, in this one machine, you're working with 7 or 8 machines maximum in Citrix or VMware. But here, so this is why 192, 168, 100.0, 100.0 subnets we are working with. So guys, here IP addresses. So what we need to do is next 3 minutes. Next 3 minutes we need to discuss this, and we're not missing out any point here. So what we need to discuss, I'm going to number them so that we know that what we need to discuss. So guys, we're going to start from here. So when discussion, we're going to start. And if I see anybody not discuss this, come here and discuss in front of the class. It's very important, guys. It's very important. So here, it starts from, we will start when our discussion starts from here. Here, first of all, we need to discuss our architecture. In our class segment, we have 3 servers. one server, second server, third server, two are server 2012, one is Windows 7. They have network cards, they have IP addresses, they are all connected to one network. So this is what we started from. And if you want, you can discuss the roles on them as well. These are the roles that we installed. And secondly, today's topic is IP address. IP address, it's a unique number assigned to 2.1. Say this definition. Unique number assigned to all network devices. And what type of devices? 2.2 is computers, servers, smartphones. So they all need IP addresses. And then we started with here, IP addresses. IP addresses are of two types. 3.1, we have Ipv4 address. It's an older technology. And then here, it is made up of a decimal number. So 3.2 made up of decimal number. It's a 32-bit address. And then it has 4 octets. And then it has, each octet has how many bits? 8 bits. And then each bit here, it shows each bit is here. And when we calculated, we said this is 2 raised to the power 8. It came out to be 256. So these are 256, but it is converted. If you convert it, if you use it, it will be 255. So don't worry about that. So here 2.5 and 2.6, 3.6 here is, where is 3.6? Yes, in 3.6, yes, here we discussed number 3.6. Here the IPv6 address, and IPv6 address is a newer technology. It is 1.8-bit address, and then here it's a hexadecimal address. And right here we were discussing here, which is number 4. We have a decimal scheme. We have 4.1, which is a binary scheme, and we have 4.2, which is a hexadecimal scheme. And right from here we jump on to this. Actually, right from here we discuss something about total number of IP addresses. So 3.6 and 3.7 here. What is 2 raised to the power 32? Total number of IPv4 addresses are 4.3 billion. And then we started discussing about 5. Number 5, so number 4 is all this. Number 5, network. Network is of how many types? 2 types. It is private network and public network. Private network can be 5.1, a home network, and then a small company, and then large company. And then right here we started thinking about, and right here we 5.4 is public network, which is examples are B. Here we discussed about number 6 here, classes. So number 6 is classes. Class A 6.1 and class B and class C. Right from here, number 7, we started discussing about subnet mask. What is the one definition for subnet mask? Subnet mask, guys, always remember that subnet mask is like, remember your home address. So here you have a street address differentiated from your home address. So your street address is your network address, and unit is your home address. Guys, we are humans, are we? So who is not saying yes? Somebody said yes. Okay, we are all humans. We do understand. We are all humans. We do understand this as soon as it comes. But guys, these routers are machines. They don't understand. You have to give them a way in order to distinguish between a network address and a host address in a IP address. So this is why subnet masks are invented. For subnet mask, it has to be, so wherever you see 255 under the octet, it becomes a network address. So here, network address, and host address. And applying this formula in class A, class B, class C, this becomes class A because the network address is just first octet. This becomes class B because the network address is first 2 octets. And then this becomes class C because C. And then comes a very important thing, that this subnet mask also gives us the number of usable IP addresses. So if it is a network address first 3 octets, you cannot use them. These are not usable, only the last one will be used. Now the next question, how many IP addresses can you have here? 2 raised to the power 8. So here 2 raised to the power 8 gives you 256 IP addresses, among which first and last cannot be used. So this gives you 254 IP addresses. Don't worry about that last one. So guys, these all points we need to discuss right now, right here. Guys, honestly, even if you don't understand, say all these words. You have to say all these words. So you have exactly 5 minutes, and then start from here. So the person sitting on my left explanation. So